Hello students, now we shall find an expression or will discuss the effect on the electrical resistivity. The factors affecting the electrical resistivity. The factors affecting the electrical resistivity. We know that the resistance of a conductor is given as below. R equals M upon E square N tau L upon A, where M upon E square N tau equal to resistivity. Of the material of the conductor. So rho is inversely proportional to N, where N is the number of free electrons per unit volume. When N is the number of free electrons per unit volume. In the conductor. These are different in different conductors. The number of N is different for different conductors. So resistivity is the natural property of the conductor. Second, rho is also inversely proportional to tau. If tau decreases, then rho increases. If we consider two atoms on increasing temperature, they spin in this way. This mean free path decreases. So tau is equal to mean free path upon BRMS. On increase the temperature, this free path decreases, hence the lambda also decreases, or this relaxation time decreases. This decreases, then resistivity increases. It means resistivity is directly proportional to the temperature. On increasing temperature, the relaxation time tau decreases. Hence, rho increases. On increasing the temperature, thus rho is linearly increases with temperature, with increase of temperature. If we draw a graph between the temperature and the resistivity, then we get like such. But some conductor like copper has no linear increase in resistivity with temperature. In this case, like this, T and K0. Third, the effect on next one, the effect on the resistivity of semiconductor. The effect on resistivity of semiconductor of temperature. The resistivity decreases with the increase of the temperature because the electrons moving in the outermost orbit or in the valence band jumps to the conduction band and its conductivity increases, hence the resistivity decreases. On increasing the temperature of semiconductors, or on increasing or on increasing the impurities, the resistivity decreases. temperature, and this is rho of this increases like this one. And next one, effect of temperature on the resistivity of insulator. Decreases with time. With temperature. The expansion equation rho is equal to rho e to the power upon 2 kT. It is also decreases, and its graph is also like this one. This is temperature, and this is rho. This is all about the effect, the factors affecting the electrical resistivity. Again, we know that the equation of the resistance are equal to m upon E square n tau L upon A, where rho is the resistivity of the material of the conductor, n is the mass of the electron, E is the charge on the electron, n is the number per unit volume, and tau is the relaxation time between two successive collisions. Rho is directly proportional to 1 upon n, or we can say rho is inversely proportional to n. If n increases, then resistivity decreases. It means conductivity increases. Similarly, resistivity is inversely proportional to the relaxation time tau. As the temperature increases, the distance between the two atoms or the mean free path decreases, hence the tau lambda upon Vrms also decreases, hence the resistivity is directly proportional to the temperature. On increasing the temperature, the relaxation time decreases, hence the resistivity increases, and the graph is linear to the temperature. But some conductors does not follow this law, like copper, their resistivity increases non-linear this way. In case of the semiconductors, resistivity increases with the increase of the temperature, because the free electrons increases. On increasing the temperature, the electrons moving in the outermost orbit jumps to the conduction band, and conductivity increases, resistivity decreases. Since the resistivity and the temperature is like this. Similarly, in case of the insulator, the resistivity also decreases with the increase of the temperature, according to the exponential equation. Rho is equal to rho naught E to the power E upon 2 kT, where E is the electric field or T is the temperature. Now this is all about the factor affecting the electrical resistivity. Okay.